Hello everyone, welcome to our channel. In this video, we are going to see chapter 1 real numbers exercise 1.4 first sum. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So before going into the sum, we have to know whether what is a rational number and what is a irrational number. So rational numbers will be of the form P by Q and irrational numbers will not be of the form P by Q. So we can say the perfect squares are all rational numbers. We can say root 4, root 9, root 16, root 25, and it goes on. All the perfect squares are rational numbers. So what is a terminating and non-terminating values? So terminating values, it stops at a particular point after the decimal place. Say for example 4.5, it is a terminating value. 2.34, it is a terminating value. 3.66, it is a terminating value. So non-terminating values are those it will be continuous and it will not stop at a point. Say for example, if we take any number, for example root 2, if I find the decimal value for root 2, I will have 1.41421356 and it goes on. It will not stop after 6 also. It goes on. So if we see this number, this is non-terminating and non-repeating or non-recurring. And these type of decimal values are called irrational numbers. So when a decimal value is given, if we need to find whether it is a rational or a irrational number, we can say that when it is non-terminating and non-repeating, it is a irrational number. When it is non-terminating and repeating, it will be a rational number. So here we are going to find whether the given rational numbers are terminating or non-terminating. If they are non-terminating, we have to check whether they are repeating. So before going into the sum, we have to know that the rational numbers are the form P by Q as I already said, but the Q value, the value of Q should be of the form 2 to the power n into 5 to the power m. If it is to the power n and 5 to the power m and where n and m are non-integers, then it will have a terminating decimal expansion. So we are going to check. We have to be thorough with the theorems 1.5, 1.6 and 1.7. So now we will check whether the given value is a terminating decimal expansion or a non-terminating decimal expansion. So we have to take the value of Q first, 3125. So as we have done in the prime factorization method, the same way we have to do here. 5 6 times, we will have 1 as a reminder, 5 2 times and 5. Again 5 125 times, 5 25 times and 5 5 times and 5 1 time. So here the denominator part is 5 to the power 5. So this 5 to the power 5 can be written as 1 into 5 to the power 5. So 1 can be written as 2 to the power 0 into 5 to the power 5. Since we have to represent the value of q in the form 2 to the power n and 5 to the power m, I am writing in place of 1 as 2 to the power 0. Since any number to the power 0 is 1. We know that any number to the power 0 is 1. So this one can be written as 2 to the power 0 since I want to place the value of 2 in this so that I can bring it as a terminating decimal expansion. So we can say it is of the form 2 to the power m into 5 to the power m, that is 2 to the power 0 into 5 to the power 5, and hence 13 by 3125 is a terminating decimal expansion. The same way we have to do the other subdivisions. So in the second subdivision they have given 17 by 8. Now we have to check the q value, that is this is of the form p by q. So I am taking the q value 8. So when I do prime factorization method, I will get 2 4s are 8, 2 2s are and 2 1 time. So the denominator can be written as 2 cube. Here I have 2 to the power something, but I don't have 5. So it can be written as 2 to the power 3 into 1. So this one I can write it as 2 cube into 5 to the power 0. So this denominator value 8 can be represented in the form 2 to the power n into 5 to the power m. So it is of the form 2 to the power n into 5 to the power m, and hence 17 by 8 is a terminating decimal expansion. So without doing the long division method, we can find whether the given rational number is a terminating value or a non-terminating decimal expansion by using the denominator, and we should check whether the denominator is of the form 2 to the power n and 5 to the power m. If any one of the number is missing, we can bring it as we did here, that is into 1 and 5 to the power 0. Same way the before sum we brought in place of 2 and 5, except 2 and 5 if we have any other prime number, that is if we have into 3 to the power 2, then it will be considered as a non-terminating and repeating decimal expansion. The third subdivision they have given 64 by 455. Now I am going to take the denominator value q, 455. So 5 tables, 5 nines are 45 and 5 one time. 7 one time, 7 threes are 13 is a prime number, it goes one time. The other things are also prime number and 13 will go one time. So if we check here, the denominator value is 5 into 7 into 13, but it should be of the form 2 to the power n and 5 to the power m to bring it as a terminating decimal expansion. So we can write it as it is not of the form 2 to the power n into 5 to the power m. Hence, 64 by 455 will have a non-terminating decimal expansion. The fourth subdivision, they have given 15 by 1600. So now I am going to take the Q value 1600 to 8 times 0 0 to 4 times 2 and 250 times 25 times and 5 times and 5 1 time. So this Q can be written as, that is 1600 can be written as 2 to the power 6 into 5 to the power 2. So if we see here, it is of the form 2 to the power n into 5 to the power m. So it is having a terminating decimal expansion. The fifth sum, they have given 29 by 343. So when I take the Q value 343, I am dividing it by 7. Since when I check with 3 it is not divisible, then it will not be divisible by 5. Then I am checking it with 7 since it is an odd number. So 7 4 times 28, 6, 7 nines are 63. 7 time and 7 1 time. So if you check the Q value, here it is not of the form 2 to the power n and 5 to the power m. So which is not of the form 2 to the power n into 5 to the power m. Therefore, 29 by 343 is a non-terminating decimal expansion. The sixth sum we will be seeing in the next video. Thank you.